Hello and welcome back to another video of Calc Nerd. So today's video is going to be on a program that I have made that converts binary numbers to decimal numbers and decimal numbers to binary numbers. So it's a pretty neat program, so I hope you do stick around for that. And I'll also teach you how the stuff is converted, like how do you convert a decimal number to a binary number? How does that kind of stuff work? And then I'll show you something else that you might find interesting. So yeah, stick around to the end and let me show you how the program runs. Okay, so let me run program bindes here, which is binary decimal. So it's going to start you off with a menu here, and it's going to ask you, do you want to convert a decimal number or a binary number, and then also exit, because when you do finish converting your number, it does bring you back to the menu here, which is why I included an exit, so you can just exit that without having to use the on key to exit the program. So when it says decimal, it means that a decimal number to a binary number, so you're given the decimal and you want to convert it to binary, and the same with binary, you're given a binary and you want to convert it to decimal. So that's how that works right there. So we're going to start off with a decimal number, and I'm just going to do the decimal number 10, not to confuse anybody, but 10, or I could do something like 11 or something like that too. Any decimal number will work, any binary number will work, up to e to the 99, which is 99 digits, because that's just too long for the calculator. So then binary, I'm just going to do the 1010 because that was 10 in decimal. So when it converts it, it should come out with 10, and it does, so that is a good sign that your program is working. You can also do that to check it after you're done programming. That's a good way to check it. So now I'm going to teach you how a decimal number is converted to binary and also the opposite. It does work in pretty much the same way, so I'll teach you that in just a second. So let's go with the decimal number, we'll do 27, sure. Okay, so that is 11011. So in binary, there's only ones and zeros. There's two numbers, so it's 2 to the whatever power, 2 to the number of digits power. So this is the 0th digit. I know that kind of sounds weird, but it is the 0th digit because any number to the 0th is a 1. So if you have 79 to the 0th, it's a 1. Anything to the 0th is a 1. And there's also debate if 0 to the 0th is a 1, which I could make a video on that if you guys would like that. And I can show you an interesting way that you can kind of say, that is pretty interesting. So yeah, if you want to make me to make a video on that, head down to the comments and let me know. So 2 to the 0th, 2 to the 1st, because that's the second digit, but it's the second minus 1. You could also do it that way. So 2 squared, 2 cubed, and 2 to the 4th. So you have 2 to the 0th, which is a 1, so that's a 1, okay? 2 to the 1st, which is a 2, so that's 2 plus 1, which is 3. You don't have any 2 squareds, so no 4s, but you do have a 2 to the 3rd, which is an 8. And so you do have an 8, so that is 8 plus the 3, which would be 11. And then you have a 16 right here. 16 plus 11 is 27. And if you're wondering how I got the 16, well, that's 2 to the 4th, which is 2 times 2 times 2 times 2, which would be 16. So that is how you quickly convert like that. You can also make a little chart if you want. Like you could write it out and do, okay, 2 to the 0th, how many do I have? I have 1, okay? And then you tick mark all that stuff. That is actually the way that I like to do it. So you can do it like that, or you can kind of just do it like this too, just kind of in your head. And I do have the obvious proof here as well because I do know the decimal number. So I'm going to now do a binary number. Let's do 100101. Sure, sounds good to me. 37, okay. So now we're getting to a little bit higher numbers here. This would actually be a 32, right? Yeah. Okay, so you have a 2 to the 0th, which is 1. So all odd numbers are going to have a 2 to the 0th at the end because you obviously squaring 2 or cubing 2, whatever you do to it, you can't get an odd number, which is why the 2 to the 0th power is included. That is why that is. So then you have 2 to the 1st, which you don't have any of. 2 squared, which is a 4, okay? So 4, and then this is a 32. So 32 plus 4 would be 36, plus your 1 would be 37. If you're wondering how I got 36, remember, you go 2 to the whatever power it is, or whatever digit it is, minus 1. So this is 2, and it's the first digit, but you have to subtract 1, so it's a 0. So I guess you can do the equation 2 to the n minus 1 if you'd like to do that. So this is the 1, 2, 3, 4, 5th, 6th digit. So 2 to the 6th, but minus 1, so 2 to the 5th, and 2 to the 5th would be 32. And it's kind of useful to know, like, it goes 2, 4, 8, 16, 32, 64, 128, 256, 512. It's useful to know that kind of stuff when converting to decimal and that kind of stuff. And then there's also hexadecimal, which is base 16, which could be a topic also on a future video. So if you'd like to see that, you can let me know down in the comments. It's actually a really interesting thing where you don't just use numbers, you actually start using letters to represent numbers because it's 16 for every digit. It gets pretty crazy. So yeah, if you'd like to see that, let me know. And then I'll just show you really quick that exit obviously does exit the program. So stick around for the tutorial on how to program this, and then I'll teach you a really neat thing that a friend and I invented. So yeah, stick around for that programming tutorial. Okay, now let me show you how you can make program bin des on your own calculator. So label 3, and the reason that I don't do clear home first, I know I said I normally do clear home first, is because when you go back, you also want to clear home, so you don't have anything on there. So that is why I don't do clear home first, because label 3 is after you've done, like entered your decimal number, let's say, and then you click enter, it goes back to the beginning, which is that label 3 there. So that is why I have the clear home there instead of normally having it at the beginning. Menu, binary/decimal, and you can also name the menu whatever you'd like. I thought binary/decimal looks nice. It also is a good description of the program so you know what you're doing. Quote decimal, comma 1, comma quote binary, comma 2, comma quote exit, comma 4. Label 1. So if you went to 1, that means you're doing a decimal number. So this is converting a decimal number into the binary. So input decimal into D, and you can also have that little colon there. And also quote and 1 space store into string 1. Repeat until D is equal to 0 if you have a not statement, and then nothing else after it. It's whatever is here is equal to 0. That's an easy way to kind of remember that. D divided by 2 store into D, sub quote 0, 1, quote, comma 1 plus not, F part of answer plus, or sorry, answer at 1, and then plus string 1 store into string 1. I part of D store into D, so the integer part of D store into D, and end. Expression sub string 1, comma length of string 1 minus 1 store into D. Display D. Pause, and then go to 3, which is the beginning there. Label 2, so this is your inputting your binary number, and you can also just put bin or something like that if you want more space to input a binary number. I find that typing the whole word is kind of nice just to see what you're doing, I guess. But you can make the program however you would like. So input binary into string 1. Del var D, so we're getting rid of D, whatever it could have been before, or it could have even been 0, but we're just making sure. For I, comma length of string 1, comma 1, comma negative 1, so go backwards. That's what the negative 1 at the end of a for loop means. If, quote, 1 is equal to sub string 1 at I, comma 1, so just one digit in string 1, D to the plus 2 to the power of length of string 1 minus I store into D. End. Display D. Pause. Go to 3 and label 4. That is the entire program. It's a relatively simple program and pretty short too. It's very compact. I actually got this code from TI Basic Developer. I will have a link down in the description of the video if you want to check out the actual pages that do a little bit more describing on like how it works and that kind of stuff. I find that kind of stuff fascinating. And if you do too, I recommend you do check it out. So with that, thank you for watching, and I'll show you something in just a second, which is kind of neat. So yeah, I hope you enjoyed today's video, and as always, I'll see you in the next one. Okay, so I'm just going to teach you just a little bit about binary hand signals. It's a thing that a friend and I started doing a couple years ago. It's been kind of a neat thing that we did. So I'm just going to pull up decimal here. And let's say, for example, you want the letter, I don't know, because A would be 1, B is 2, C is 3, and so on and so on. Every letter in the English alphabet would have a number. So let's say, I don't know, you can pick from anything here. I don't know, why not the letter I? So I would be 1, 2, 3, and that's 5, 6. Okay, so that is the 9th letter of the alphabet. So I put in a 9. It's going to give me 1, 0, 0, 1. So 1, 0, 0, and a 1. So this would be I. So that is how that works. So A, B, C, so on, so on. And you can keep doing that and change different stuff around as you see fit. Obviously, there's different stuff that is kind of like, you could change that or make this a different thing just to make it a little bit harder to crack. So that's kind of a fun thing that you can do with your friends. You can obviously add some more stuff because you do have up to 31 on one hand because you have 5 fingers. So yeah, it's just kind of a fun thing that you can do. Thank you for watching today's video. I hope you did enjoy, learn some stuff about binary, and maybe you can try binary hand signals with some of your friends. Yeah, so thank you for watching, and I'll see you in the next one.